I'm standing in place for Matthew, who had to go do something else. And I had quite an easy role because we actually only had one group in our challenge. That doesn't detract from their work. They've done a very good job. They've done some cool stuff using Bitcoin and BitChain technology to create an app, a messaging app with extra security, things that could be useful for celebrities recently. So I have one winning team, and I'd like to bring them up here. So, surprise, we have currently some GitHub subscriptions, which also work as an IOU for when Matthew comes in. Okay. So we will be contacting you.
That's her team name. And if you didn't know about the challenge, it was Matthew Chalmers basically said, use the blockchain that Bitcoin uses and do something with it. So we have the full freedom to do whatever we want with it. And go to the next slide, please.
So the main part of the challenge was to integrate somehow the Bitcoin and blockchain technologies, which basically consists of blocks, like the ones on the slide, that are connected to each other and only backwards, not from the first one to the latest one.
So why did we decided to use this challenge? When you think about social media currently, everyone is worried about their privacy, and Bitcoin is really secure because you always hash the previous block and you can't roll back to the previous message. That loses your history, but it's still there, present. So we decided to take this challenge because of security reasons and privacy reasons, as you can see on the board. Next slide, please. Where can you see such technology? Anyone use Snapchat? Right. Yay! One guy in the back. Okay, for what I know, Snapchat takes photos, you send them to your friends, and they disappear, right? So we go for something like this. You send a message. Once you leave the network, the message disappears, and nobody can see it. Do you know about the Hong Kong protest, right? Okay.
Of course.
Of course. Basically, there are guys that developed a fire chat app that's run on Bluetooth. So basically, the protesters can chat with each other even without internet, but that information wasn't encrypted. So we did something similar. We basically send our message to a local network, but with encryption. And lastly, how secure is it? On top of the hashing that we use with the blockchain, we also encrypt our data for the user that wants to see it. So, guys like this can't spoof your data. How is it implemented?
So we used a TCP server to transmit the data and UDP server to find all the peers inside the network. And then the other important part of the implementation was the Bitcoin chain, which is actually quite hard to get to the real implementation that's used in the main chain. So we did our closest implementation, and you will see it soon after the demo.
Yeah. Basically, we ping the network on broadcast. We get the users back. Every user sends a key, that's his encryption key, and you can basically broadcast messages encrypted with the key that the user sent you. And they use the other key pair, their private key, to decrypt the message back. And now we're going to show you a demo how this works. But we actually have to SSH the pointer because Aileron is blocking the broadcast tag IP. Sorry. So we're basically going to connect to 2 or 3 or 4 separate machines and start chatting with them through the terminal and see the messages coming through.
So how exactly does the client identify another device that actually has client software on it?
You basically broadcast, and if someone is running the app, they will reply back. It's done on UDP, it's pure discovery.
So
The peer discovery is not our code. We got the peer discovery, but the TCP connection that we make after it is our code.
So we can set messages, anything to the other one, and also reply back. After a few messages, we can print the blockchain.
Respect it.
And I'll try to make it bigger so you can see it. Still bad, but so you can see the time of each blockchain, the height of each node, and also the message and the hash of the current one, and also the link, which is printed on every second line, the link to the previous node, which makes it so secure.
Is this one with the encryption? Or?
No, this will not.
Okay, so this one works without the encryption. You can basically have as many people reading the messages that you send to the local network, and once you disconnect, those messages are gone. Even if there was a conversation before you connected, you only guess the latest message and not the ones before, which makes it so secure. And if you actually run the other thing with the encryption, we can show you as well the key pair that you're sending through. So this is the key that we receive back. We basically create a key pair. We have a public and a private key, and the messages arrive encrypted. And you use your private key, they're basically encrypted with your public key, and use your private key to decrypt them back. And if someone spoofs this, they'll see only hashes and encrypted data. Yay! And that's it.
This laptop here, okay? Yeah, you can collect it after 10 minutes.
Yeah, fair enough.
Yeah.
So I'm wondering, it seems like if someone was watching the network, it would be quite easy to build up a picture of individuals who are using it all the time, even though you couldn't read it. Is that right? Because you can see the keys transmitted all the time.
Yeah, the blockchain is passed around to every user.
No, I meant the GPG or PGP keys or whatever you use.
Yeah. But you still can see what's inside. Doesn't Bitcoin work that way?
But you're still going to be seeing the keys and when it happened and which device and the MAC address. But, okay.
Fair enough.
At what point does the private key system generate the key pairs? How does the user plan the private key?
We basically make a handshake in the beginning. So when you start the app, you generate a key pair, and once another user pings you, you send a response packet with the key inside.
How's that response package encrypted?
It's not. There's every other person that you're going to talk to should have your public key unencrypted like it is, and that's why it's public. And then only with your private key, which is generated together with the public key, you can decrypt the message that's encrypted with your public key.
Does it make sense?
So if I want to send a message to somebody, I'll encrypt this message not with my keys, but with his public key. So he can decrypt it with his key. So that these two keys, the public and the private one, are linked as pairs.
Anyone else?